Around 300 BC, the renowned Chinese poet and philosopher Tri Yuan pondered the origin and evolution of the universe in his poem, The Quest for Infinity. It became a transcendent inquiry through time and space. In 1956, Tsung-Dao Lee and Chen-Ning Yang introduced a groundbreaking theory on parity non-conservation in weak interactions, opening a new chapter in our understanding of the origin and evolution of the universe. Fast forward to 2016, at the suggestion of T.D. Lee, Tsung-Dao Lee Institute was founded at Shanghai Jiao Tong University. Here, we focus on the origin and evolution of matter under extreme cosmic conditions, carrying on the quest for infinity since ancient time. To unravel the mysteries of the dark universe, we are building a cutting-edge spectroscopic telescope atop the 4,300-meter summit of the Saishiteng Mountain in Lenghu, Qinghai, one of the world's best observing sites for astronomy. This telescope that will peer into the deep cosmos is known as JUST. In the universe, another puzzling entity emerges: dark matter. Its mass surpasses known matter by a factor of 5, yet its true nature remains elusive. TDLI is dedicated to uncovering the dark matter particles. In the Jinping Mountain in Sichuan, a tunnel located 2,400 meters from the summit serves as a direct detection site. The thick rocks surrounding the lab effectively absorb cosmic rays, resulting in one of the lowest radiation background facilities globally. Within this best environment, a liquid xenon detector operates and named Panda X.
We hope that future discoveries will be originated from here to unlock the deepest mystery of the universe.
Our focus now moves to neutrinos. Conventional telescopes allow us to view our universe by capturing the electromagnetic radiation produced by celestial objects. But when trying to observe the most violent and energetic processes in our early universe, this light is often easily blocked on its journey to Earth. Neutrinos are tiny, neutral particles that are unaffected by electromagnetic barriers, making them a novel messenger to probe the extreme universe. Leaping into this realm, TDLI leads the construction of an underwater neutrino detector 3.5 kilometers deep in the Western Pacific Ocean. The detector will be strongly shielded from cosmic rays, viewing the entire neutrino sky from its equatorial position. It expects to be world-leading in size and sensitivity compared to existing neutrino telescopes.
We are here at TDLI building a next-generation neutrino telescope called Trident.
Let's return to Zhangjiang, Shanghai, where 3 specialized platforms are at work. The Laboratory Astrophysics Experimental Platform employs high relativity lasers to generate celestial-like extreme physical environments for simulating the evolution of celestial bodies. The Topological Materials Experimental Platform focuses on the discovery of novel topological materials and the realization of next-generation electronic devices. Augmenting our capabilities, we possess Xiyuan-1, one of China's foremost high-performance computing centers among universities. It provides essential simulation and computational support for scientific research.
So black holes are often referred to as the most mysterious object in the universe. They are one of the most extreme cosmic conditions. CWM Mark 1 provides the critical technology support for our research for the astrophysical black hole.
At TDLI, we have a close interplay between top-notch theoreticians and pioneering experimental collaborations.
My research focuses on the quantum field theory of the early universe. Our goal is to investigate the fundamental principles that govern the formation and evolution of matter in extreme cosmic environments. And I think that this research aligns very well with the scientific questions that Professor T.D. Lee addressed in his impressive scientific work.
My research focuses on superconducting and magnetic materials. In addition, I collaborate with Professor Kim Xiang-Kav on organizing my own facility in Shanghai. Within a year of my starting, I moved my whole family from Germany to Shanghai. Scientists are highly respected here.
While our members actively engage in diverse international collaborations, we are committed to organizing various cutting-edge international activities and fostering alliances to promote fundamental science globally. With almost 40% of our scholars being international, diversity is deeply cherished within our vibrant community. Our faculty, having studied or worked globally, enrich our academic environment. English serves as our working language. We have welcomed visitors from 180 prestigious research institutions worldwide. Additionally, our dedicated administration team offers professional support to everyone.
In our quest for pioneering fundamental science, Tsung-Dao Lee Institute aims to be a global magnet, attracting scientists from diverse backgrounds. Here, we foster an inclusive environment where brilliant minds can thrive and unravel the deepest mysteries of the universe. The cosmos awaits. Join us on this exciting journey.
Around 300 BC, the renowned Chinese poet and philosopher Tri Yuan pondered the origin and evolution of the universe in his poem, The Quest for Infinity. It became a transcendent inquiry through time and space. In 1956, Tsung-Dao Lee and Chen-Ning Yang introduced a groundbreaking theory on parity non-conservation in weak interactions, opening a new chapter in our understanding of the origin and evolution of the universe. Fast forward to 2016, at the suggestion of T.D. Lee, Tsung-Dao Lee Institute was founded at Shanghai Jiao Tong University. Here, we focus on the origin and evolution of matter under extreme cosmic conditions, carrying on the quest for infinity since ancient time. To unravel the mysteries of the dark universe, we are building a cutting-edge spectroscopic telescope atop the 4,300-meter summit of the Saishiteng Mountain in Lenghu, Qinghai, one of the world's best observing sites for astronomy. This telescope that will peer into the deep cosmos is known as JUST. In the universe, another puzzling entity emerges: dark matter. Its mass surpasses known matter by a factor of 5, yet its true nature remains elusive. TDLI is dedicated to uncovering the dark matter particles. In the Jinping Mountain in Sichuan, a tunnel located 2,400 meters from the summit serves as a direct detection site. The thick rocks surrounding the lab effectively absorb cosmic rays, resulting in one of the lowest radiation background facilities globally. Within this best environment, a liquid xenon detector operates and named Panda X.
We hope that future discoveries will be originated from here to unlock the deepest mystery of the universe.
Our focus now moves to neutrinos. Conventional telescopes allow us to view our universe by capturing the electromagnetic radiation produced by celestial objects. But when trying to observe the most violent and energetic processes in our early universe, this light is often easily blocked on its journey to Earth. Neutrinos are tiny, neutral particles that are unaffected by electromagnetic barriers, making them a novel messenger to probe the extreme universe. Leaping into this realm, TDLI leads the construction of an underwater neutrino detector 3.5 kilometers deep in the Western Pacific Ocean. The detector will be strongly shielded from cosmic rays, viewing the entire neutrino sky from its equatorial position. It expects to be world-leading in size and sensitivity compared to existing neutrino telescopes.
We are here at TDLI building a next-generation neutrino telescope called Trident.
Let's return to Zhangjiang, Shanghai, where 3 specialized platforms are at work. The Laboratory Astrophysics Experimental Platform employs high relativity lasers to generate celestial-like extreme physical environments for simulating the evolution of celestial bodies. The Topological Materials Experimental Platform focuses on the discovery of novel topological materials and the realization of next-generation electronic devices. Augmenting our capabilities, we possess Xiyuan-1, one of China's foremost high-performance computing centers among universities. It provides essential simulation and computational support for scientific research.
So black holes are often referred to as the most mysterious object in the universe. They are one of the most extreme cosmic conditions. T-wave Mark 1 provides the critical technology support for our research for the astrophysical black hole.
At TDLI, we have a close interplay between top-notch theoreticians and pioneering experimental collaborations.
My research focuses on the quantum field theory of the early universe. Our goal is to investigate the fundamental principles that govern the formation and evolution of matter in extreme cosmic environments. And I think that this research aligns very well with the scientific questions that Professor T.D. Lee addressed in his impressive scientific work.
My research focuses on superconducting and magnetic materials. In addition, I collaborate with Professor Kim Xiang-Kav on organizing my own facility in Shanghai. Within a year of my starting, I moved my whole family from Germany to Shanghai. Scientists are highly respected here.
While our members actively engage in diverse international collaborations, we are committed to organizing various cutting-edge international activities and fostering alliances to promote fundamental science globally. With almost 40% of our scholars being international, diversity is deeply cherished within our vibrant community. Our faculty, having studied or worked globally, enrich our academic environment. English serves as our working language. We have welcomed visitors from 180 prestigious research institutions worldwide. Additionally, our dedicated administration team offers professional support to everyone.
In our quest for pioneering fundamental science, Tsung-Dao Lee Institute aims to be a global magnet attracting scientists from diverse backgrounds. Here, we foster an inclusive environment where brilliant minds can thrive and unravel the deepest mysteries of the universe. The cosmos awaits. Join us on this exciting journey.
Around 300 BC, the renowned Chinese poet and philosopher Tri Yuan pondered the origin and evolution of the universe in his poem, The Quest for Infinity. It became a transcendent inquiry through time and space. In 1956, Tsung-Dao Lee and Chen-Ning Yang introduced a groundbreaking
in China in order to allow more public to access the legendary stories of this physics giant. CCTV4 National Memory Program, in collaboration with the Shanghai Jiao University, has jointly planned and produced a 3-episode documentary titled Master Tsung-Dao Lee. So, the documentary is divided into 3 major chapters: Preaching the Tao, Imparting Knowledge, and Resolving the Doubts. It combines in-depth interviews, tracking records, and precious historical materials to comprehensively restore Mr. Lee's master efforts. So this is not only a biographical documentary, but a record of the times, carrying the national pride, scientific spirit, as well as patriotic sentiment as well. So ladies and gentlemen, so let's watch the trailer for Master Tsung-Dao Lee together. In 1959, represented by Tsung-Dao Lee, we're at the culminate of the world scientific world, so trying to uncover the truth and trying to understand that, for example, the non-conservation of the parity. However, the achievement of becoming a Nobel laureate in physics is not the finishing part of his story, but is the beginning part of his lifelong journey for his contribution to China. He has always been a patriot. He has firm belief in the development of China and tried all the means he can to assist with the development of China. I believe that at a crucial juncture for China's development history, and so for the nation and the government officials, he had advised them on the very practical tips as to what he thinks will be the appropriate solutions. And he is a scientist of the lecture hall. At the same time, he initiated a lot of programs like CUSPA, so collaboration between China and the US for the high energy physics, as well as the Beijing electron and positron collider and postdoc mechanism, as well as a national Nature Science Foundation, as well as our CURE Foundation, and using his own efforts and wisdom is blazing the trail for China in the future. He's a real role model and idol. You can feel his energy and mentality. He is a very passionate person. So he has inspired generations of young people like me, including me as well, mentoring me to lead my path towards physics. Well, over the past few years, so for China's scientific development as well as talent training, I have done something for very simple purpose, which is to make sure that on the world stage, Chinese people once could stand up upright and feel proud. So this is a very simple conviction that has been running true throughout his life. So undoubtedly, I believe that Tsung-Dao Lee is a great scientist and he is a very respected person, not only because of his academic achievement, but he is very patriotic as well. So a physics giant with the deep affection for his motherland, China. So I guess that his mastery journey doesn't stop with exploration of the cosmos, but also lies in the inspiration of future generations, imparting knowledge and also giving people the means to achieve their life achievements and resolving all the problems. So this is paying tribute to Master Tsung-Dao Lee. So thank you for watching the trailer for documentary. So this is about epic, writing about all the achievement of a master, heartfelt tribute across time and space, and a transmission of the spirit and carry on the legacy for the future as well. So here today, the producer of the documentary, Mr. Zhao Bing, producer of the CCTV's National Memory Program, has already been coming here on site for our commemorative event. Ladies and gentlemen, let's express our sincere gratitude to him and the production team. Thank you so much, everyone. We believe that this deeply affectionate work of tribute will surely allow the spiritual light of Mr. Lee's deciphering the cosmos, exploring the matter to reach far, to illuminate the path forward for more successors. So throughout his more than 6-decade academic career, Mr. Tsung-Dao Lee pursued a rigorous scholarship in many fields like quantum field theory, elementary particle theory, nuclear physics, statistical mechanics, and fluid mechanics, and astrophysics. He strived for the new heights and also make a lot of breakthroughs as well. He's scaling the peaks of the science and making fundamental enduring contribution to development of physics. Let's welcome Commemoration Wang Yifeng, former director of the Institute for High Energy Physics, the Chinese Academy of Science, delivered the first keynote report. So Tsung-Dao Lee, the physics giant, introducing his academic achievement and the scientific contribution of Professor Tsung-Dao Lee. Welcome. Professor Chongqing Zhang Jie. So, distinguished leaders and experts, ladies and gentlemen. So, during my part, I'm going to do a presentation for you as part of our commemorative events for commemorating the 100th anniversary for the birth of Professor Tsung-Dao Lee. So I'm going to do some recapture of the past 6 decades of academic life career, as well as his prominent contribution to science world as well. So the organizer for the conference, so Chinese Academy of Sciences, so the Institute of High Energy Physics, as well as Frick's Advanced Center for example, the research. At the same time, so the Beijing University and the Institute of Tsung-Dao Lee Institute as well. So the point about the holding of this event not only is to do a capture of his prominent contribution to the modern physics, but also is trying to become a very good inspiration for the generations to come, to make sure that you can understand and appreciate his efforts more. At the same time, we understand that his academic achievements as well as his major and pivotal contribution to the world of physics. So on the 1st of March, we held our commemorative event, and back in the year 1949, on the same date, he published his first academic paper. So that's why we designated the 1st of March as the marking the beginning of his academic career. So think about interaction of mesons with nucleons and light particles, the first published academic paper. This is historical landmark.
Well, his first paper was quite historical and hold a very significant milestone in the history. So the venue of this symposium is in the auditorium of the Zhongguancun Basic Science Park. So here, Mr. Li has held and chaired and participated in many academic activities, as you can see from the photos. So Mr. Li has participated in a lot of academic symposium in this auditorium. In this symposium, we have a lot of speakers and presentations. Academician Chen Heshen share about this high-energy accelerator in China, and Professor Shoji Nagamiya, he made a presentation about his memory and his recording of Mr. Li's contribution to the heavy ion physics. Professor Shoji Nagamiya is also present today, and he is also going to make a speech later. Also, we have invited Professor Ji Xiangdong to touch upon Mr. T.D. Lee's contribution to the parity violation and his academic achievements, especially the most important, the parity violation law. And academician Wu Yueliang made a speech about T.D. Lee's contribution to the CP violation. Academician Luo Mingxing made an introduction about Mr. Lee's quantum field theories, and also we had the Professor Norman from Columbia University, a student of T.D. Lee. He also introduced Mr. Lee's contribution to the lattice QCD. And the researcher Zhou Shun from the IHE-PCAS made a presentation about Mr. Lee's contribution to the neutrino, and Professor Holger Stocker from the Goethe University Frankfurt, Germany, he introduced T.D. Lee's contribution to the nuclear matter. The class peer, one of the students of Mr. Lee, Professor Ren Haichang, made a speech about Professor Lee's contribution to the condensed matter, and Professor Li Xingzhen from the Beijing University also introduced Mr. Lee's great contribution to the statistics. This academic symposium was moderated by Cao Jun, the director of IHE-PCAS, academician Gao Yuning from Peking University, and also the researcher Mr. Zhou from Institute of Theoretical Physics, researcher Wang Chuiling from CCAST. This academic symposium was also joined by academician Zhang Jie, Wang Yifang, and Professor Li Zhongqing. So here is a short video about this symposium. So please play this video.
The International Symposium on Modern Physics in Memory of T.D. Lee.
去年李先生8月4号去世以后，我阅读李先生324篇论文的过程当中，他呢是在量子 场论、基本粒子理论、核物理、统计力学、流体力学、天体。
So he has made a great contribution to the quantum field theories and also the other theories.
Energy accelerate. The construction of the BPC provided China with their own energy physics base, guiding the rapid progress over 4 decades.
We sincerely hope his profound legacy will continue.
Okay, let's start the second half of the morning session.
TD initiated the Caspia program, helped thousands of Chinese physics students to enter graduate schools in U.S.
Mr. T.J. Lee is a theoretical physicist and Nobel laureate. He proposed this parity violation, laying a solid foundation for the physics.
For his tremendous contributions to quantum field theories.
And in the first session, we have 3 speakers. First,
TD's vision and creations and guidance played a large role in this frontier level of physics that we're.
He is always optimistic about particle physics.
Person 21 years old. When I first heard of him, I was a student in there, and he was very excited about
PhD student of Professor Lee. Let's welcome.
And Professor Lee once remarked that a physicist would be proud for his life or her life. And Professor Lee, he is among the greatest theoretical physicists.
That the series of phase transition is fundamental in physics, and the work of Li and Yang is seminal in the sense that it provides a unified mathematical framework.
It's actually the first paper published by Professor T.D. Lee 76 years ago. After 76 years, to celebrate and to review the great contributions of T.D. Lee, I think it's very significant and meaningful.
Physics was really very much his life. So many great people took the opportunity to then go on and do so much, and he would just be so proud. So.
下面我们
Next, let's have a review of Mr. Lee's academic contributions. As we all know, the greatest contribution is the parity non-conservation in weak interactions proposed by Tsung-Dao Lee and Zhenyi Yang in 1957. He won the Nobel Prize in Physics, and he has an disruptive change of the people's understanding of the fundamental science. So in the history of the physics, this discovery was a milestone. And this discovery has also led to the foundation and the proposal of the two-component neutrino theory and establishment of the universal VA theory as well as the standard model. At the same time, prior to that, the two physicists have made a great contribution to the physics, especially in the statistical mechanics. In 1952, they published a paper, The Phase Transition Theory, in the statistical mechanics. This has served as a fundamental essay and paper for those researchers involved in this field and the researchers. You have to study this paper. And in this paper, the unit circle theorem is a very fundamental research work. In terms of the quantum field theory, he and his peer has proposed a very important research For the superconductive DCS, he has made great contributions. And Schiffer once proposed that it has directly influenced the proposal of the BCS theory of superconductivity. So this is a great contribution by Mr. Yang, a very fundamental and a milestone contribution to the BCS. And in 1954, he proposed the Lee model in quantum field theory, the only renormalizable model to date. It is also a very key breakthrough and contribution to the quantum field theory. Also, he has proposed the theory of non-topological solitrons in quantum field theory, as well as the spontaneous violation of the charge parity symmetry. He wants to find out the root causes, the source of the CP violation, although this problem remains to be solved. He has been very actively promoting a new direction of research, which is the RHIC, relativistic heavy ion collisions, both in the theory and the experiments. Now, these heavy ion collision experiments around the world are actually proposed by Mr. Lee and his peers in the experiments. So he has made great promotion work, and this experiment has become a very important research direction. A lot of larger size accelerators have already been established, or some of them are underway in the world. So here we have listed 4 accelerators under construction and 2 in operations. So since the 1970s, he established this research direction, and to this date, it's still a very frontier of a scientific research. At the same time, he also supported and advocated for the LQCD, and he is one of the founders of LQCD. He and his students have been promoted the LQCD, and he personally have facilitated the founding and establishment of the large computing device for the QCD computing. So far, it's still a very important research direction, or to put it in other words, in order to solve the courses of the QCD, this computing device is the only way out. So in this new context, in this new environment, with the very advancement of the computing industry, also we have this machine learning and quantum computing, it is highly possible that based on the LQCD and also the QCD technologies, we can accomplish all the calculations for the QCD, so we can fulfill all the tasks and also the requirements by the QCD. As we all know, Mr. T.D. Lee has promoted initiation and construction of the Beijing Electron Positron Collider, BEPC. There are a lot of twists and turns in the development of China's and high-energy accelerators. So we finally made it happen. So we call it 7 twists and 8 turns. And at the last try, we finally achieved the success. And this success was attributed to the active advocacy and support of Mr. Lee, or otherwise we will go through maybe 7 twists and 7 turns. And he has been very active in supporting this endeavor, and he has made great contributions. And without him, that we will not have this high-energy physics in China. So throughout the journey, Mr. Lee has took on enormous pressure and the risks. A lot of people say this is only a dream. This high-energy physics in China really lack the resources, technologies, foundations, and also the human resources. This is an impossible dream. And some people even think this is just a pipe dream. And at the end of the day, the high-energy physicists in China, along with Mr. T.D. Lee, have resolved all the technical bottlenecks and have successfully established this BEPC. And during this journey, Mr. Lee has taken enormous pressure and risk. He has also staked all his reputation on this career. And at the end of the day, we have overcome all the fundamental bottlenecks and technology difficulties, and also establish the BEPC and contribute to the high energy physics in this industry. Without the contribution and advocacy of Mr. Lee, we cannot make this happen. As a famous theory physicist, he has been very pioneering, and also he has really contributed to the success of the experimental physics. In 1988, the BEPC achieved the first collation. It took 4 years to complete the construction. Even in the Western world, it is unprecedented.
One week following the successful experiment, and then the back then leaders, Deng Xiaoping and other government leaders, has already traveled on site, which is with the company of Tsung-Dao Lee. And so at the same time, so a lot of thank you words has been expressed as well. Because of the success of the BEPC, we understand that actually because of that, so you find that the Spear Collider project has already been put on the standstill. So actually they send their delegation to participate in China's successful event. So this marks the beginning of the Sino-US collaboration for scientific experiment. At the same time, so in the past we only humbly contributed to the global efforts, but now we have our own indigenous efforts as well. So you'll find that the US also contributed several billion US dollars. So this is a remarkable progress as well. So as a result of that, this project actually produced a lot of, for example, results, precise measurement of the tau lepton mass, verifying the lepton universality, precise measurement of R value at the same time, the discovery of new particles as X, etc. So we believe that on the basis of this, we have already embarked on a journey for the high energy physics. At the same time, you'll find this is laying a solid foundation for accelerate as well as the physics. So you'll find that actually, the Beijing synchrotron radiation light source and the Shanghai light source, as well as the other different technologies, has been developing very solid on this basis of that as well. So without Professor Tsung-Dao Lee, I believe that there will be no the booming development for China's large-scale scientific devices. So at the same time, you'll find that actually for the BPC, after more than 10 years of successful running, so Professor Tsung-Dao Lee has been proactively supporting the upgrading and retrofitting of the BPC into version 2 as well. So you'll find that a double ring design has been advocated by him. At the same time, writing a letter to the Chinese government and also trying to ask us for some funding to make sure that as a result of that, retrofitting can be successfully completed. As a result of that, promoting the development of theoretical development as well. So as a result of that, you'll find that actually this has been so successfully completed. So there are a lot of results and achievements of BPC2 and the best third. So 600 the paper has been published, of which 120 has been carried by our top academic journals as well. At the same time, you'll find that in terms of the article publication per person, you'll find that the BPC, you'll find that the best third has already been the most prolific. So you'll find that so LCB, Bell2, and Atlas, and other programs, so the per author production is double of what our international counterpart is producing for other projects as well. So that is to see that actually we have been very prolific in the output and achievements we had. So looking back, so this is the best decision we could have made back then. So with a lot of academic implication, with great fruits and results. So with 4 decades spending about 880 million. So as a result of that, so productive scientific output produced by the high energy physics here in China. This is an expensive endeavor, but if you average that by the years, and if you average that out with the people involved, we don't spend more than others. So at the same time, so he has proactively been promoting the Daya-1 still neutrinos experiment as well. And by his personal great efforts, you'll find that at the same time, you'll find that he has been proactively promoting the Daya-1 project for the neutrino experiment. And so think about the proportion as well as the project establishment and the scientific research, and prominently promoted the Chinese and the US government to make sure that large-scale neutrino project has been supported. And also the US and China collaboration has been achieved made possible as well. At the same time, he personally engaged in the theoretical research as well. He had already published a lot of related academic paper about the physical experiment for neutrinos as well. So think about his latest published paper actually is about 2010, which is about the physics study for the neutrinos. And then ever since then onward, so there are no more like original physics paper that has been published, and all the other subsequent paper published for the study of physics are about his review and comments on others. So as the project for Dia 1 has been coming to a successful end, we find that we have been talking about, for example, the physics study of a neutrino in the era of the Dia 1 project. Aside from this one, you'll find that he is the first one to read our paper as well. So you'll find that our collaboration special task force agreed with consensus that prior to submitting the paper, so to some extent, you'll find that we're trying to create some new rules to make sure that someone outside of our special task force have been able to read our article. So he's the person who gets to read our article who is not on our special task force. So we pay tribute for him. And following his reading of our paper, on the next day, he is sending us a congratulatory remarks. So he is actually inspiring us and also feel very happy about the achievement by his younger generations. So as a result of that, so Professor Tsung-Dao Lee is the physics giant from the 20th and 21st century, contributed milestone achievements like parity, non-conservation, and also the phase transition theories, and Lee modern fields of symmetry physics and quantum field theory and neutrino physics and phase transition theories as well. So because of him, we have a lot of booming large-scale devices that make a huge leap forward. So we will keep in our permanent memory his contributions to our experimental physics. Thank you so much. And high energy physics. Thank you. So thank you very much, Academician Wang Yunfang. So the scientific achievements of Professor Lee expanded the boundaries of human knowledge, and his educational practice illuminated the path of learning for countless students. So he devoted his efforts and through a series of pioneering initiatives as, for example, the Gifted Young and Caspia and postdoc scheme, as well as the foundation, cultivated the soil and nurtured a lot of seedlings for the future of Chinese science as well. So let's come to the second keynote report. So Professor Tsung-Dao Lee, Education as Foundation, three guests is going to share their insights on. So Professor Lee's educational philosophy. Let's welcome academician Lin Haiqing. Welcome. Morning, ladies and gentlemen. So I'm the alumni member from the 1988 Caspia program. So my name is Lin Haiqing. I'm the Dean of the School of Physics at Zhejiang University. It's my great pleasure to report you on the occasion of the 100th anniversary for the birthday of Professor Tsung-Dao Lee. So we understand that I'm going to brief you on the symposium on the Tsung-Dao Lee's academic thoughts held at Zhejiang University in Hangzhou this year. So let me give you the background as well as the process symposium as well as the inheritance of Mr. Lee's people-oriented education spirit. So Professor Tsung-Dao Lee is a world-renowned scientist or Nobel Laureate in physics, made pioneering landmark achievements in quantum field theory, elementary particle theory, nuclear physics, statistical mechanics, and fluid mechanics, and astrophysics. As a patriotic Chinese person who promoted the development of China's science and technology education undertakings, he facilitated the establishment of the special class for gifted young and the establishment of Caspia, as well as the establishment postdoc program at Natural Science Foundation for China, has done a lot of prominent contributions. At the same time, he has already single-handedly initiated epoch-making, historically important Caspia program, where he cultivated a lot of leader generations as well as pillars of society. So this unique alumni conference, you'll find that the Inspire programs at the Caspia program has already been leaving a lot of spiritual, scientific mark and legacy for us as well, the CGP program. And in his alma mater, we have the academic thoughts seminar for Tsung-Dao Lee, which is the alma mater. So in Zhejiang University, this is a great tribute for him. So I believe that this unique conference actually trying to commemorate and contribute to the commemorative events for the 100th anniversary of King's birth, and since the 1978, 9, and 1989. So this is about celebrating renowned 4 projects between China and the U.S. So you'll find that the China-U.S. Physics Examination Application Program, at the same time the Cooperative Chemistry Graduate Programs, the Tsung Institute of Mathematics Programs, alumni, and all the cohorts of the special class for gifted young students at the University of Science and Technology for China. As is known to all that apart from his physical achievements, so achievements in physics, so Mr. Tsung-Dao Lee is very proud of the CAS PhD and EA program. You'll find that the special class will give to the young and the China postdoc program as well. So actually self-initiated by our alumni members in the campus of Zhejiang University. A lot of alumni members use their own out-of-pocket money and funding to travel here to attend our ceremony. So the 84 different CASPIA members, as well as from the talented young programs, have already been traveling there and trying to pay tribute to Professor Tsung-Dao Lee. So, and following that, we still actually gather together as for China Science and Technology, like University of China. At the same time, we have already promoted all the other different programs that followed that as well. So this is the blazing the new trail for that. Between 1979 to 1989, there are 3 other programs similar to the CASPIA that help the Chinese students study in the United States. So CASPIA and the CDP, as well as the Chinese Institute of Mathematics program. So it supported a lot of young generations of scholars to the tune, respectively, of 915, 425, and 242, and 140. So 1,722 scholars have been spread to the other different nations around the world, leading the global academic, technology, financial fields, forming a formidable research force. So what once nurturing, like the spring breeze and gentle rain, has grown into forests of peaches and plums as well. To express the gratitude to Mr. Tsung-Dao Lee, so decision has been made by the alumni members as we are trying to commemorate the occasion of the Tsung-Dao Lee's 100th birthday. We are going to have the theme of the people-oriented education to cherish memory of his kindness in the symposium started at Zhejiang University, which because 82 years ago, the 17-year-old Tsung-Dao Lee traveled hundreds of miles on foot to Guizhou amidst the warring period, and seeking the Zhejiang University, which had relocated westward to Zunyi and Meitan in Guizhou province for schooling at a time. And so Professor Tsung-Dao Lee back then didn't have the formal diploma from high school. Zhejiang University allowed him to take the university entrance examination in the Guizhou examination area as equivalent academic qualification candidate. And then he was successfully admitted to the electrical engineering department of the Zhejiang University with high scores, and then transferred to the Department of Physics. And this is the registration card for his academic achievement back then during his 1-year tenure at Zhejiang University. And undergraduate study in Zhejiang University has already become a memorable memory for Professor Tsung-Dao Lee. And he has always had, Zhejiang University in his mind, always paid special attention to the development of his alma mater. And as Zhejiang University is celebrating 100th and 110th and 120th anniversary, he sent congratulatory letters across the ocean as well. So between 1979 and 1989, when CASPIA has been in operation 10 years, so 30 students has been promoted to go for further studies for Zhejiang University, of which 9 has attended our conference here today. So I'm going to report you on the situation of symposium held in Hangzhou. First of all, we'd like to thank the members of Symposium Organizing Committee. Thank you for their hard work, which contribute to the success of Symposium. So the Organizing Committee includes Li Zhongqing, the eldest son, so the CASPIA, and CGP, as well as the Tsung Institute of Mathematics program, as well as the teachers coming from University of Science and Technology for China, as well as Secretary General of the New Alumni Foundation. Successful holding of the symposium is not possible without dedication from Zhejiang University Organizing Committee. In order to ensure the smooth conduction of the symposium, Zhejiang University Preparation Committee organized meticulously collaborative the university partners, held successful preparation meetings and university collaboration meetings. Zhu Hui, so Deputy Secretary of the University University Party Committee has personally provided a guidance and to make sure all the details handled out successfully, and also to show the highest respect for Professor Tsung-Dao Lee as well as other predecessors. Symposium had brought alumni together from thousands of miles apart to keep the appointment, and these photos recorded scenes behind the scenarios on the stage of the symposium, and also trying to keep in a permanent memory of our gratitude and longing for him. So 99 alumni members and together with their spouses participating representatives totaling 157 people attended the symposium in Hangzhou, and also 300 faculty members as well as students from Zhejiang University attended as well, of which 90 people actually went to pay homage at the Tsung-Dao Lee and his wife's cemetery in Suzhou after the conclusion of our Hangzhou symposium on the 30th. So the Hangzhou symposium was held on the June 28th and 29th, and 27th is registration day, and the 30th is the time when actually everyone went to the Suzhou to pay tribute. At the same time, during the meeting, you'll find that official beginning day is the 28th, and the president actually of our university delivered some remarks as well. So at the same time, he mentioned that we should transform the spiritual wealth left by Tsung-Dao Lee into the driving force, continuous struggle, and integrate academic thoughts of people-oriented education with university's education philosophy centered on students' growth, and also cultivate a new growth of young people who can take responsibility of a national the nation.
And then Lin Haiping, cosplayer 1980, representing the Zhejiang University School of Physics, delivered a speech titled "The Master's Virtue as High as the Mountains, as Long as the Rivers," commemorating Dr. Lee's deep concern for the Chinese science, technology, and higher education. And Academician Zhang Jie, director of the TDLI, stated in his speech that it was T.D. Lee, with his patriotism and foresights, who sowed the seeds for the cultivating science talents and pointing the way forward for us. He emphasized the unwavering commitment to build the TDLI into a world-class hub for scientific innovation, talent development, ensuring the continuous inheritance of the Chinese science. Wang Chunling, 1979 cosplayer, spoke affectionately, "When drinking water, we should never forget who dug the well." As we deeply remember Dr. Lee, who devoted his life to cultivating talents for the motherland, we must pass on this spirit. No matter where we are, we shall follow his example and always remember contributing to the motherland is the responsibility of every Chinese. Sun Xiaohong, 1982 cosplayer, stated that Professor Rui Wu and Xiao Chenggu devoted their life to promoting academic research. Of Dr. Lee and Dr. Rui Wu is being passed on to a new generation of scholars, and the conference special guest, Director General of the Professional Technical Personnel Management Department of the Ministry of Human Resources and Social Security, and Director of the Office of the National Postdoctoral Management Committee, Mr. Li Jing, also highlighted these main aspects of Dr. Lee's involvement in this postdoc program. And Xue Ziling, 1984 CGP, mentioned in his report, this opportunity for advanced study in the U.S. brought about a dual transformation in both personal growth and career development. And Li Zhenqing, and along with the students, Wei Shenbing and Liu Zhongqian, presented the contents and the analytical results of their long-term research. And also, the CUSPIA program helps in better understanding the globalization Chinese characteristics. And these alumni have also shared with us about their overseas studying abroad. And also he commemorated and appreciated Mr. Lee. So within 2 days, like over 20 reports. So we are considering how to really carry on the spirit of Dr. Lee. So reviewing the past, Mr. Lee is not only caring about all the young people, but also creating new opportunities to pursue science and technology. Mr. Lee has made a great contribution to the fostering of the young talents in science and technology. And he has also speaking about his early study experiences. And one of these students, one of the teachers of Mr. Lee is Su Xinbei from the Zhejiang University School of Physics, and also another Professor Wang Changjing from the Physics School of Zhejiang University. So during his study in the Zhejiang University, he has solely completed his initiation into physics. So today, the Zhejiang University School of Physics, inheriting the spirit of a predecessor and guided by our mission, is committed to cultivating top-notch innovative talents. We have also established the ideal brand of being Wanggengchang style and also cultivating the Chenjiangkang style outstanding students. And also in 2023, and this scientific spirit education base was selected as a national scientist spirit education base. And also in recent years, alumni from the Zhejiang University School of Physics have continued to grow into leading figures in the industry, such as Wang Zhen, Ma Jian, and Chu Xiang. In recent years, the physics at Zhejiang University has developed rapidly, entering the ranks of the world-class disciplines. And so we still have a long way to go into the future. We believe the best way to commemorate is through striving. We'd like to pass on the torch. We're grateful to Dr. Lee and inherit his legacy and guidance. Thank you very much. Thank you, academician Lin Haiqin. Next, let's invite Caspier scholar and Dean of the School of the Gifted Young at the USTC, Lu Zhentian, will share with us based on the practical history of the gifted young and Dr. Lee's philosophy on talent selection and educational wisdom, and summarize the Hefei session of the Education's Fundamental TD Lee Alumni Assembly. Let's welcome Professor Lu Zhentian. Distinguished Professor Li Zhongqing, academician Zhang Jie, distinguished guests, faculty members, and students. So today, I'd like to share with you Nurturing Talent, TD Lee Alumni Assembly Hefei session, and a brief introduction of the alumni of SGY. For the Hefei session, we have arranged 23 reports and 2 roundtable discussions. The reporter for the Caspier projects include Mr. Zhang Yongde, a retired professor of Caspier. He organized the students to participate in the Caspier exam with outstanding achievements. He was referred to by students as the Devil Coach. He has also made these resources into a book, and I believe a lot of students are still learning from this book. And Professor Xu Yixie shared his memory of doctoral study in Columbia University and the mentorship by Mr. Li. And Mr. Wang Zhonglin introduced the frontier developments of nano industry and encouragements by Dr. Li. And Zhang Zhenyu from the USTC is also a very outstanding coach. He has coached 40 undergraduate students for scientific research programs. So one of his students is Cao Yuan, is the class 2010. During his PhD in the MIT, due to his graphene research, he was selected as the Nature 10. And during his undergraduate, he has studied this graphene. His first paper was under the guidance of Professor Zhang Zhenyu. So this is a great example. The Caspier alumni return to the homeland and teach the students and to pass on the knowledge to the future generation of science. Also, this session was joined by the alumni from the Chen Project, CGP, and also the Caspier Project. The alumni have shared with us their memories and experiences and takeaways about Dr. Li. And Mr. Ren Jiadong from the Ministry of Human Resources and Social Security, he recounted that in 1984 and 1990, he wrote letters to Deng Xiaoping twice, initiating and this postdoctoral system, and he has also submitted his ideology and design. And Mr. Liang said, Mr. Li is the advocate and the founder of the postdoc system in China. So, dear the faculty members, if we read the letters from Mr. Li, you can see he proposed the establishment of a exchange and the flow of young talents, not only the talents from the overseas market, but also the domestic research institute. It is important to select talents from exchange of those young talents. And Su Gejun, the CPC Committee Party Secretary of CUST, has also recounted Mr. Li's contribution. He is a great initiator and also promoter of the School for the Gifted Young. He also served as a bridge for scientific research. So this USTC museum, along with our Hefei session, is now initiating a memorial exhibition. Also online, you can scan the QR code and also have access to all the materials and resources. Also, we like to share that kind of resources and the legacies of Dr. Li with the TD Lee Library. And Yan Huiyun, member of the Central Committee of the Zhoushan Society, had a great exchange with Mr. Li. And also on the QR code, we come of the SGY, there is a great memory of their letters. So they had both great relationships and friendships, and they had a common goal of nurturing talents. In 1983, Mr. Yan's letter to Mr. Li stated that about the Caspia program, under this initiation support of Mr. Li has entered into an official trajectory. So it has also proved a great friendship between China and the U.S. in science and education. It will speed up the development of Chinese physics. 10 years later, the Chinese physics industry were prospering. I was expecting that you should come with me to witness this prosperous development of physics industry. Mr. Yan also sent his greetings to Janet, the wife of Dr. Li. So about the founding of School for the Gifted Young, Mr. Li recounted that to initiation of a School of a Gifted Young in the university is quite related to my suggestion on talent cultivation in 1974. So Mr. Li was very proud of the School of Gifted Young. He really cared about the growth of this School of Gifted Young. He has really made a lot of contributions. So in 1984, he made an inscription for this SGY 10th anniversary. Mr. Li, when he visited the USTC, he had a meeting with the students of SGY. There were 2 photos from our dossier. I would like to share with you 2 anecdotes. So in this photo, this little boy is Tu Yuhai, the class of 1983. He turned his head around. He's not looking at Mr. Li, but he's looking at Xu Jun, this lady. And after that, he pursued Madame Xu Jun, and they get married. And their children, or we can say the second generation of School for Gifted Young, are also outstanding talents. So actually, it is a great memorial. And this Tu Yuhai is a researcher in the theory physics. In 2020, he received this Laureate on Second Prize by the American Physical Society for his profound and groundbreaking contribution to the group physics motion. And he said this pioneering work of Mr. Li has changed many lives of the future generation. And also I met Mr. Tu and I met Mr. Liu in 2002, and in which areas that we need to develop further. And he said, if you are not the first, you will be behind. So it has been inspiring me. In 1987, I joined the Caspia and studied abroad in the US. And in the 1993, I returned to China. Also, from the secrets, I also benefited a lot. So Mr. Tu Yuhai has been following the steps of Mr. Li, and a lot of us have the same sharings. the second story, actually we can see this is another photo. So standing beside Mr. Lee is Madam Chen Xiaowei. During his university, she has received a great award in making speeches, and then she became the director and also the CCTV host and producer. So after she made a presentation, a lot of people say they are the followers of her health popularization video account, Dr. Xiaowei, and she also is a graduate of the SGY. Later, after the session, she also published a video named Because of Him, Our Parody is No Longer Conserved. It has reached a total playback volume of 1.2 million. So I'd like to play this video. One afternoon, when I received the notification from Mr. Ye, asking me to go to the office of SGY, there is an important figure coming to visit us. Many years later, in the dossier, and they discovered this photo and sent to me and asking me why I look so nervous in the photo. I said, maybe back then I will know he is the most important figure I will ever meet in my life. So this time I came back to our alma mater and the place where I met Mr. Lee. I would like to say to Mr. Lee, thank you for changing my life. So now I have leveraged all the life science knowledge to make a popularization video. I'm very healthy. I'm very happy. That's it. Thank you.
谢谢。
Thank you so much. Quite a coincidence that this year is a 100th anniversary for the birth of quantum particle theory. So of which academician Pan delivered a wonderful presentation talking about the past, the current status quo, as well as the future of quantum. So let's try to take example of the quantum informatics. So to try to let you understand, the alumni members graduated from the talent young. So the 1985 class, Zhu Jiangfeng. So the quantum physicist, the academician of Chinese Academy of Sciences, and the deputy minister of the Chinese Ministry of Education, who used to be the former president of Zhejiang University. So Chen Yuao, 98 class. So you'll find the executive president of the Physics Institute. At the same time, so for example, win an award for exploring of the physics. So you'll find that Hu Yu, so who is the founder of the quantum company, and also the Deng Yunhao. So you'll find that actually, so the key person for the prototype, like for example, quantum machine, and also the most beautiful student in the year 2022 as well. So these are the prominent leading examples of a lot of alumni members who are prominent at the forefront of the quantum technology. In the process of preparing for the meeting together with Professor Li Zhongqing, we had a communication with Professor Li Zhongqing and arrived at a consensus. He also showed the deepest tribute as well as pass on the educational philosophy of Tsung-Dao Lee. So we decided to develop the scholarship on honoring the Professor Tsung-Dao Lee to acknowledge a lot of excellent students who are studying home and abroad. We believe that this is a personal honor for a lot of scholar winners as well. So we believe that this is going to constantly encouraging the young scholars to try to cultivate the cultivation of the generations and expand their global horizon. So Li Zhongqing and Li Shanshi, thank you very much for your support for our foundation and the scholarship, and also thank you for granting awards for the first winners of our gifted young talent program winners of the Tsung-Dao Lee Fellowship and Scholarship. Thank you. So thank you very much, Professor Lu Zhengtian. So CURE, ever since its establishment, has already been celebrating the 27th anniversary, and so trying to expose the undergraduate students to understand the frontier of science and technology, and trying to create opportunities to do the innovation. So Lanzhou University actually is one of the prominent university to establish this program. So let's welcome the Deputy Party Secretary Lanzhou University to share with us of the story between this CURE Foundation Endowment as well as Lanzhou University. Welcome. Honorable Professor Li Zhongqing, Director Zhang Jie, distinguished leaders, honorable guests, my friends, ladies and gentlemen, good morning. So today, with the deepest respect and the most profound reverence, we are commemorating the centennial birthday of Professor Tsung-Dao Lee, who not only forged immortal monument in the history of the world of science, but also his profound patriotism as well as the selfless dedication to science and education inspired generations of Chinese students to devote themselves to science, and also providing a continuous stream of spiritual strength for the nation's rejuvenation. As a representative university of the foundation, which is a CURE Endowment Foundation, so standing at the historical intersection, brimming with gratitude and legacy, reflecting on Mr. Lee's illustrious life and revisiting his care and support for the sixth, for example, the foundation universities, appreciating the path of science and light of education he illuminated for us, inheriting his noble character, hold profound significance for fulfilling our fundamental task of fostering virtue, and also cultivating a new generation capable of national rejuvenation. So for Lanzhou University, Mr. Lee's care and support have long become a spiritual beacon guiding our way forward. So there are three parts of my presentation here today. Well, the first one is that profound connection between Professor Tsung-Dao Lee and Lanzhou University and bonding with Longyuan. So Professor Tsung-Dao Lee's bond with Lanzhou University began in the early days of reform and opening up. In 1979, Professor Lee proposed the establishment of the Caspia program, which is known Caspia, China-US like a physics examination application program, opening the gate for the world-leading academic institutions for younger and talented Chinese youth. In the inaugural Caspia examination, so Hu Ting, a physics student from our university, stood out with the top score nationwide. Subsequently, our university repetitively achieved the top rankings in both team and individual scores in this U.S. graduate program examinations, and laying a very solid foundation for enhancing university's research strengths as well as global reputation. And then, during May and June 1990, the first Lanzhou International Summer School on Frontiers in Nuclear Physics was held at our university, leveraging his high prestige. So Professor Tsung-Dao Lee invited numerous leading international scholars to attend and was accompanied by his wife, so Madame Hui Chunqing, who was originally coming from the Tianshui, Gansu province. Mr. Lee also delivered an invited academic report on the relativistic heavy ion reactions. This conference accelerated integration of China's nuclear physics research with international frontier, also presented the inscription to Lanzhou University, learn from the nature, innovating in use. During his time, Mr. and Mrs. Lee planted 4 spruce trees on the Lanzhou's Baita Mountain, and these spruces stand very tall and evergreen, accompanied by the stone tablet inscribed with story. Professor Tsung-Dao Lee and his wife, Hui Chunqing, planted 4 spruce trees here and wished Lanzhou city to become an oasis of science. In August 2000, Mr. Lee returned to the Gansu and the Lanzhou University campus again, where he was appointed as the chief scientist advisor as well as the honorary professor of our university. With his consent, Gansu Provincial People's Government established the Tsung-Dao Lee Scholarship Fund to motivate students in our province universities and secondary school students to focus on their studies and scientific innovation. So Mr. Lee has left a description expressing his hopes for students and teachers of our university. Lanzhou's aura springs from the nature university talents emerge generation after generation. And then, in October 2002, he visited our Gansu for the 3rd time. So Ms. Lee attended the inaugural award ceremony for the Tsung-Dao Lee Scholarship, and where he presented certificates and awards to the recipients of 201 and 02 winners, encouraging them to study hard and dare to innovate and scale new heights. And he also came to our Yuzhong campus to attend the 4th meeting of the CURE Management Committee, presenting the certificates to the supervising teachers and representatives of scholars as well, fully affirming the foundation's achievements. And that day, during a cordial exchange with students, and asked why he chose to establish this endowment foundation at Lanzhou University, he said affectionately, well, first, to commemorate my wife, so Madame Hui Chunqing, and who was originally coming from the Tianshui, Gansu province. Secondly, Lanzhou is located at the center of the nation and the cradle of the Yanhuang culture, and the Lanzhou University is the best university in Lanzhou. And finally, and represents my profound hopes for you, for everyone. So we have high hopes for you. So the spirit of Mr. Lee has long been engraved in the cultural fabric of the university, and his care for the university has inspired teachers and students to bravely scale the peaks of science. And just as he exclaimed after viewing the Mother Yellow River sculpture while standing by the mighty river, no matter how great the challenges China is facing, the waters of the Yellow River is always flowing eastbound and eastward. So this powerful adage continues to inspire all the teachers and students of Lanzhou University to forge ahead, no matter what happens. Second one is about fruitful labor. So deep implementation of the CURE Endowment Foundation, Lanzhou University. Ever since the inception of the foundation in 1998, so we saw Lanzhou University has already joined alongside Beijing University, Fudan University, Suzhou University, Tsinghua University, and Shanghai Jiao University. Lanzhou University has already regarded as the seed project for inheriting the scientific spirit and cultivating the top-notch talents. So it used to cover, like for example, the physics and computer science, but it covers the social science, the humanities and mathematics and physical science and biochemical, pharmaceutical sciences and geographical sciences. It cultivated 1,021 different scholars, of which 300 attended like the summer program for the 6 foundation universities and 200 participated in the annual conference for exchanges. 50 students presented at the academic reports at the annual conferences as well. So over the past 27 years, we believe that based on our foundation, we have established management approaches at matching funds and strengthened the process manager strictly implemented the meeting mechanism and governed the usage of fund and promote the university exchanges and held experience share and soar the scholars forum. So aiming not only to train students' research capabilities, but also reshape their scientific spirit as well. So over the past 27 years, generations of the scholars winning the scholarship has embarked on their scientific journeys of inquiry, exploration, innovation from Lanzhou University, following Ms. Lee's footsteps. And the cohorts prospective of scholars have joined the Chen family, pursuing their own research dreams and innovation dreams. And also this is encouraging, for example, the fourth term scholar Xu Zhichuan had the privilege of meeting and conversing with Mr. Lee, and experience that has inspired his scientific pathway. And he has grown into a chair professor at Nanyang Technology University and become recognized as a cited researcher for 7 consecutive years. Fifth-term scholar, for example, the Xue brings an undergraduate major was geographical science, and his project is in business development. At the same time, you will find Wang Weiguang has already attended a lot of different projects as well, and now a professor at Shenyang Institute of Applied Sciences as well. So you'll find that as a key member, Wang Weiguang participated project won a gold award in China's International College Students Innovation Competition. So we have seen a lot of touching stories emerge from the family. And then in 2002, prior to his visit, so we saw a Han Dynasty iron artifact at the museum with a dozen irregular teeth and square hopes, and Professor Lee suspected it's not a transmission gear. He inquired a lot of staff working for the museum and with no answers, and with its approval. And this question in the year 2003 has been designated as the dedicated project. So Chen Ling from the physics department, through observation, measurement, and replication and cultivation, Chen Ling identified this project as a racket for braking, not a gear, and the research refundings are published in the Universal Journal. And in 2004, so the Chen annual conference, Chen Ling presented this report. Ms. Li was very happy. Oh, you answered a question I pondered for a long time. Thank you so much for giving the answer. And he mentioned evolving undergraduate research is a range of purpose for establishing the CURE Endowment Foundation, not only to require undergraduates solve the scientific problems, but by engaging in the scientific research, you can understand the whole process of scientific research so that your interest can be aroused. Your capability to identify and solve the problem can be increased. Over the past 27 years, university has built 588 strong team members of a supervisor team. The participating student guidance, mentorship, and exemplary figures had already emerged as well. Professor Wang Yuhua supervised the 7 cohorts of the scholars over 20 years, and Professor Pan Duoqiang and the 10th term Chen scholar once received the direct guidance from Mr. Li. Now himself has become the supervisor and become a key member of the Huang Danian style teaching team. So our faculty members as well as students actually has been passing on and internalizing the great scientific spirit of Tsung-Dao Lee, and at the same time this is shining brilliantly at the 20th annual conference. So you'll find that Zhu Jun, which is the self-designed mascot for our foundation, and also you'll find that so this is about the bamboo, which is metaphorically meaning that a growth of the students as well. On the occasion of the 26th anniversary of our conference, we compiled printed a path of learning established like the chain home exhibition, and the video has been formulated to pay tribute to Tsung-Dao Lee. At the same time, we're going to advance the tracking of educational outcomes from the scholar program, and also establishing what is called a chain home on the usual campus to build it in spiritual high ground for servicing the nation through science and showcase the window for educational achievements. And thirdly, passing the torch cultivation and growth of innovative talents at Lanzhou University. As the seed project, the foundation plays a pivotal role in guiding the cultivation of innovative talents. Adhering to Mr. Lee's original intent of letting undergraduates understand the process of research, enhance their interest, and improve their identification capabilities of discovering problems. In the year 2002, University initiated a College Students Innovation and Entrepreneurship Action Plan, so of which we have approved 19,407 projects to date. On the basis of that, established a program, actually universal level, national level, team like a foundation for training students at the different levels. Every year, we attracted 8,000 different universities, covering 40% of the undergraduate population, and 95% of undergraduate enrollment participating in innovation projects, competition activities. So in the process of scientific innovation, we have worked very hard as the echo and response to Mr. Lee's question proposed half a century ago. How can we establish the motherland a new young team of scientific workers?
The key to science he entrusted to the youth has grown into the fruitful forest of scientific innovation on the Yellow River. They inscribe the detachment of the delving deeper into physics. One must find joy into their lab records, and carve the composure of why being hindered by fleeting flame into their research dreams, and integrated patriotism of the entire Chinese nation is one person into every ascent they make. Distinguished guests, dear friends, now the waters of the Yellow River surge eastward. A century of changes has passed, yet Professor Tsung-Dao Lee's scientific spirit and patriotism have always shone brightly. Over 40 years of working alongside with him, his educational philosophy and expectation have been blossomed everywhere. For many years, the New Year paintings and greeting cards personally drawn and inscribed by Professor Lee were the anticipated New Year gift for every manager involved in this foundation project. Now they have transformed this cure from Professor Lee into enduring remembrance and respect. The best remembrance is inheritance. The best gratitude is taking actions. Looking forward, we will adhere to the original aspiration of educating people and deeply integrate Professor Lee's spirit with our university's ethos of striving for perfection, standing out distinctively, and cultivate innovative talents for the new era. We'll continue to promote this founding spirit and culture, making it a fertile ground for nurturing student scientific literacy and academic character, inspiring young people to dare to innovate, know how to innovate, and be confident and self-reliant. We'll always keep serving the country in mind, committed to contributing the wisdom in basic research and key fields, and also repaying Professor Lee's profound kindness and strong support from all walks of life. So we would like to sincerely thank Dr. Lee's profound support for the Lanzhou University. So thank you very much. Thank you, Mr. An. The Caspia program, initiated and promoted by Dr. Lee, opened the door to international academic exchange for Chinese students. Behind this program lies moving stories that change individual destinies and the fate of an era. Now, following Professor Lu Zhenting's introduction, let's witness the launch of the alumni interview video, and also let's recount this era of dreams and opportunities. Now, let's welcome Lu Zhenting.
在1979年。
From 1979 to 1989, Mr. Tsung-Dao Lee, Mr. Wu Rui, William Dory, and Mr. Chen Xingsheng in the physics, biochemistry, chemistry, and mathematics in these 4 fields initiated the CASPIA program and has sent over 1,700 excellent students for overseas study in the US and has nurtured a top-notch talents with great influence. So in order to commemorate their spirit and also their visionary foresight, so this year we have held the Fostering Talents in honor of Tsung-Dao Lee's Alumni Assembly this year. During this assembly, we are conducting a series of interviews with the 30 representative alumni from the CASPIA and related programs and the School of the Gifted Young at the USTC. We hope that through their stories, we can showcase the collective contributions these alumni have made to promoting the development of science and technology education in China and globally, thereby highlighting the profound significance of those programs. We believe that the life experiences and insights of those alumni will bring new inspiration to everyone and help young friends seize opportunities and meet challenges on their life paths. So here, we are going to release the trailer of the interview. Please watch it.
1979到1989年间，李政道、吴瑞、William Doering 和陈省身通过物理、生物化学、化学、数学4个中美博士生考试与申请项目，选派1700余人赴美攻读博士，培养了大批顶尖人才。
七溪集区的中国科技大学，后来在科大大概是3年级的时候吧，就参加了卡斯比亚的考试，然后去美国的芝加哥大学物理系学习物理。
我是第6届啊，1986年考试，1987年去的美国，那时候我们没有80年代的时候，中国刚开放，也没有 TOEFL、GRE， 自己不知道美国什么学校。其实我考上卡斯比亚，他们问我你想去哪个美国学校，我只知道2个学校，一个叫哈佛，一个叫斯坦福。然后哈佛还把那个英文的名字拼写了错了2个字，所以那时候一点都不知道。所以卡斯比亚确实开阔了我的视野。
Okay, when Li Xiansheng asked me to help maybe establish a parallel program to CASPIA in biology, initially I thought, oh, that's a very interesting project that it would be interesting for me to do. But the requirement in order for this project to be successful, you need somebody who's experienced and who knows a lot about China. At that time, I was only 3 years into the assistant professorship at Cornell University, so I was young. I didn't know very much about China, and I thought I could not do it, but I knew somebody who did, and somebody in my department who's a close colleague of mine, and that is Professor Ray Wu. Professor Ray Wu had always wanted to do something about helping Chinese students to come to the U.S.
我叫王爱英，我是 CGP 的节目的受益者。那我呢，可能就是走了一个不同的途径，就不是去学校。那我拿到博士，我的博士是物理化学。拿到博士以后呢，我直接进入工业。
大家好，我叫刘军，我原来是北大81年入学，85年毕业，后来参加了这个陈省身项目，然后86年出国。
比如说我在2000年有一次接受日内瓦的世界实验室的邀请，去做一个邀请报告。我知道那是一个很大的一个会，但是我不知道李政道先生也会参加那个会，所以
我上了台以后，我一看见那是一个400-500人的一个大会，李先生坐在第一排，所以我在演讲之前不免有一些忐忑，因为那是第一次和李先生这么近距离的面对面。但是我在演讲的过程当中，李先生一直含着微笑看着我，所以我心里面感到非常的温暖。
74年开始到爷爷去世，1996年，每一次李先生见到爷爷都是严老师，所有的信件都是严老师，包括他给爷爷90大寿的时候，包括爷爷住院，他给爷爷写了很多封信，所以他们之间不光有师生的友谊，他们又一起推动了少年班的成立，博士后制度的建立，这个国家自然科学基金委的成立。那么最主要的呢是 CASP， 是在爷爷和程道先生的共同努力下、共同推动下，当然这也包括科学院研究生院当时副院长吴棠先生和他领导的这个班子的努力，才会有这样一个10年的 CASP 的经历。
然后在那里学的是天体物理，到天文台观测，还有做了一些计算机模拟模式研究引力场怎么样影响那个宇宙大规模的那种structure 怎么形成。我自己觉得这个项目给我就是说一个机会，能够自己有机会去发现这些兴趣爱好和自己怎么说有点特长什么的，我觉得就能够有一个非常丰富多彩的人生这完全是这个项目给我这样的机会。
我觉得当时我们这届考哥斯比亚的时候，我们并不知道有这么一个公开的考试。我记得考了3天，就是基本上就是经典力学、电磁学和量子力学3门考试，还加上英语的考试。所以考完了以后，我们就有一个面试，面试是跟那个李先生和李先生的夫人秦慧君一起，他们问了我好多问题。别人大概的确是正规的物理训练，我这个物理训练基本上是，你可以想象，不是很扎实的。但是呢，李先生的鼓励还是让我决心去坚持就到哥大去学吧。
这个哥斯比亚对我的影响当然是非常大的，因为这个当初甚至包括今天，欧美应该还是科研呢是最前沿的。那么当初，尤其是在80年代初期，我们的科学研究呢还是比较落后。那么哥斯比亚这个项目呢，有机会让我接触到国际上最先进的科学研究，而且我的2个导师，这个研究生导师和这个博士后导师呢，都是2个非常知名的这个美国的科学院院士，所以呢，这个哥斯比亚这个项目呢，给我机会接触到最先进的科研的前沿和接触到最优秀的老师。
我觉得 CASP 这个项目改变了900多位学者的一生，他们可能本来不会走上现在这条路，所以我觉得这个对人生的改变其实是一个很大很大的事情。就这一点上来说，我觉得李先生就做到了我们对这些学子的大爱，就是他没有记任何自己的一个得失，然后他每一件事情都在帮助这些学子解决他们哪怕是最细小的问题。所以这些事情其实我觉得也教会了这些学子怎么去做人，怎么去做事，对这900多个孩子的影响其实可能比他真正自己做学问还要重要。
当时呢，这个我们国家这个经历了这个10年文革嘛，很多东西呢都中断了，百废待兴，特别是基础科学研究方面，这个和国际上当时的这个差距还是比较大。 那么李政道先生呢，他这个倡导和亲自组织了这个卡斯比亚项目呢，就给这个当时这个我们就是年轻的国内的学子吧，提供了一个机会。但他具体的倡导的这个是个物理方面的一个项目。后来呢，又有其他的一些类似的一些项目，最后就是也作为一个契机，掀起了这个可以说中国历史上第二波留学的大潮。这个呢，对这个整个中国后续的这个科学技术，甚至经济的发展都非常重要。
中国的留学潮，第一波是因为庚子赔款，第二波呢就是这个1979年到1989年这一段时间，而且是以卡斯比亚这个项目为这个代表，然后后来带动了在生物、化学、数学各方面的培养了一帮人才，这个让中国的科技，还有这个因为这些项目的培养出来的人呢，对这个中国的科技接轨，到现在整个这个中国科技的崛起，应该这第二波这些留学的人呢，应该对他是有非常大的影响的。
Well, thank you, Professor Lu, for your introduction. I would like to thank Mo Zhishalong for.
Around 300 BC, the renowned Chinese poet and philosopher Tri Yuan pondered the origin and evolution of the universe in his poem, The Quest for Infinity. It became a transcendent inquiry through time and space. In 1956, Tsung-Dao Lee and Chen-Ning Yang introduced a groundbreaking theory on parity non-conservation in weak interactions, opening a new chapter in our understanding of the origin and evolution of the universe. Fast forward to 2016, at the suggestion of T.D. Lee, Tsung-Dao Lee Institute was founded at Shanghai Jiao Tong University. Here, we focus on the origin and evolution of matter under extreme cosmic conditions, carrying on the quest for infinity since ancient time. To unravel the mysteries of the dark universe, we are building a cutting-edge spectroscopic telescope atop the 4,300-meter summit of the Saishiteng Mountain in Lenghu, Qinghai, one of the world's best observing sites for astronomy. This telescope that will peer into the deep cosmos is known as JUST. In the universe, another puzzling entity emerges: dark matter. Its mass surpasses known matter by a factor of 5, yet its true nature remains elusive. TDLI is dedicated to uncovering the dark matter particles. In the Jinping Mountain in Sichuan, a tunnel located 2,400 meters from the summit serves as a direct detection site. The thick rocks surrounding the lab effectively absorb cosmic rays, resulting in one of the lowest radiation background facilities globally. Within this best environment, a liquid xenon detector operates and named Panda X.
We hope that future discoveries will be originated from here to unlock the deepest mystery of the universe.
Our focus now moves to neutrinos. Conventional telescopes allow us to view our universe by capturing the electromagnetic radiation produced by celestial objects. But when trying to observe the most violent and energetic processes in our early universe, this light is often easily blocked on its journey to Earth. Neutrinos are tiny neutral particles that are unaffected by electromagnetic barriers, making them a novel messenger to probe the extreme universe. Leaping into this realm, TDLI leads the construction of an underwater neutrino detector 3.5 kilometers deep in the Western Pacific Ocean. The detector will be strongly shielded from cosmic rays, viewing the entire neutrino sky from its equatorial position. It expects to be world-leading in size and sensitivity compared to existing neutrino telescopes.
We are here at TDLI building a next-generation neutrino telescope called Trident.
Let's return to Zhangjiang, Shanghai, where 3 specialized platforms are at work. The Laboratory Astrophysics Experimental Platform employs high relativity lasers to generate celestial-like extreme physical environments for simulating the evolution of celestial bodies. The Topological Materials Experimental Platform focuses on the discovery of novel topological materials and the realization of next-generation electronic devices. Augmenting our capabilities, we possess Xiyuan-1, one of China's foremost high-performance computing centers among universities. It provides essential simulation and computational support for scientific research.
So black holes are often referred to as the most mysterious object in the universe. They are one of the most extreme cosmic conditions. CUN Mark I provides the critical technology support for our research for the astrophysical black hole.
At TDLI, we have a close interplay between top-notch theoreticians and pioneering experimental collaborations.
My research focuses on the quantum field theory of the early universe. Our goal is to investigate the fundamental principles that govern the formation and evolution of matter in extreme cosmic environments. And I think that this research aligns very well with the scientific questions that Professor T.D. Lee addressed in his impressive scientific work.
My research focuses on superconducting and magnetic materials. In addition, I collaborate with Professor Kim Xian-Kav on organizing my own facility in Shanghai. Within a year of my starting, I moved my whole family from Germany to Shanghai. Scientists are highly respected here.
While our members actively engage in diverse international collaborations, we are committed to organizing various cutting-edge international activities and fostering alliances to promote fundamental science globally. With almost 40% of our scholars being international, diversity is deeply cherished within our vibrant community. Our faculty, having studied or worked globally, enrich our academic environment. English serves as our working language. We have welcomed visitors from 180 prestigious research institutions worldwide. Additionally, our dedicated administration team offers professional support to everyone.
In our quest for pioneering fundamental science, Tsung-Dao Lee Institute aims to be a global magnet attracting scientists from diverse backgrounds. Here, we foster an inclusive environment where brilliant minds can thrive and unravel the deepest mysteries of the universe. The cosmos awaits. Join us on this exciting journey.
Around 300 BC, the renowned Chinese poet and philosopher Tri Yuan pondered the origin and evolution of the universe in his poem, The Quest for Infinity. It became a transcendent inquiry through time and space. In 1956, Tsung-Dao Lee and Chen-Ning Yang introduced a groundbreaking theory on parity non-conservation in weak interactions, opening a new chapter in our understanding of the origin and evolution of the universe. Fast forward to 2016, at the suggestion of T.D. Lee, Tsung-Dao Lee Institute was founded at Shanghai Jiao Tong University. Here, we focus on the origin and evolution of matter under extreme cosmic conditions, carrying on the quest for infinity since ancient time. To unravel the mysteries of the dark universe, we are building a cutting-edge spectroscopic telescope atop the 4,300-meter summit of the Saishiteng Mountain in Lenghu, Qinghai, one of the world's best observing sites for astronomy. This telescope that will peer into the deep cosmos is known as JUST. In the universe, another puzzling entity emerges: dark matter. Its mass surpasses known matter by a factor of 5, yet its true nature remains elusive. TDLI is dedicated to uncovering the dark matter particles. In the Jinping Mountain in Sichuan, a tunnel located 2,400 meters from the summit serves as a direct detection site. The thick rocks surrounding the lab effectively absorb cosmic rays, resulting in one of the lowest radiation background facilities globally. Within this best environment, a liquid xenon detector operates and named Panda X.
We hope that future discoveries will be originated from here to unlock the deepest mystery of the universe.
Our focus now moves to neutrinos. Conventional telescopes allow us to view our universe by capturing the electromagnetic radiation produced by celestial objects. But when trying to observe the most violent and energetic processes in our early universe, this light is often easily blocked on its journey to Earth. Neutrinos are tiny, neutral particles that are unaffected by electromagnetic barriers, making them a novel messenger to probe the extreme universe. Leaping into this realm, TDLI leads the construction of an underwater neutrino detector 3.5 kilometers deep in the Western Pacific Ocean. The detector will be strongly shielded from cosmic rays, viewing the entire neutrino sky from its equatorial position. It expects to be world-leading in size and sensitivity compared to existing neutrino telescopes.
We are here at TDLI building a next-generation neutrino telescope called Trident.
Let's return to Zhangjiang, Shanghai, where 3 specialized platforms are at work. The Laboratory Astrophysics Experimental Platform employs high-relativity lasers to generate celestial-like extreme physical environments for simulating the evolution of celestial bodies. The Topological Materials Experimental Platform focuses on the discovery of novel topological materials and the realization of next-generation electronic devices. Augmenting our capabilities, we possess Xiyuan-1, one of China's foremost high-performance computing centers among universities. It provides essential simulation and computational support for scientific research.
So black holes are often referred to as the most mysterious object in the universe. They are one of the most extreme cosmic conditions. CUN Mark 1 provides the critical technology support for our research for the astrophysical black hole.
At TDLI, we have a close interplay between top-notch theoreticians and pioneering experimental collaborations.
My research focuses on the quantum field theory of the early universe. Our goal is to investigate the fundamental principles that govern the formation and evolution of matter in extreme cosmic environments. And I think that this research aligns very well with the scientific questions that Professor T.D. Lee addressed in his impressive scientific work.
My research focuses on superconducting and magnetic materials. In addition, I collaborate with Professor Kim Xiang-Kav on organizing my own facility in Shanghai. Within a year of my starting, I moved my whole family from Germany to Shanghai. Scientists are highly respected here.
While our members actively engage in diverse international collaborations, we are committed to organizing various cutting-edge international activities and fostering alliances to promote fundamental science globally. With almost 40% of our scholars being international, diversity is deeply cherished within our vibrant community. Our faculty, having studied or worked globally, enrich our academic environment. English serves as our working language. We have welcomed visitors from 180 prestigious research institutions worldwide. Additionally, our dedicated administration team offers professional support to everyone.
In our quest for pioneering fundamental science, Tsung-Dao Lee Institute aims to be a global magnet attracting scientists from diverse backgrounds. Here, we foster an inclusive environment where brilliant minds can thrive and unravel the deepest mysteries of the universe. The cosmos awaits. Join us on this exciting journey.
Around 300 BC, the renowned Chinese poet and philosopher Tri Yuan pondered the origin and evolution of the universe in his poem, The Quest for Infinity. It became a transcendent inquiry through time and space. In 1956, Tsung-Dao Lee and Chen-Ning Yang introduced a groundbreaking theory on parity non-conservation in weak interactions, opening a new chapter in our understanding of the origin and evolution of the universe. Fast forward to 2016, at the suggestion of T.D. Lee, Tsung-Dao Lee Institute was founded at Shanghai Jiao Tong University. Here, we focus on the origin and evolution of matter under extreme cosmic conditions, carrying on the quest for infinity since ancient time. To unravel the mysteries of the dark universe, we are building a cutting-edge spectroscopic telescope atop the 4,300-meter summit of the Saishiteng Mountain in Lenghu, Qinghai, one of the world's best observing sites for astronomy. This telescope that will peer into the deep cosmos is known as JUST. In the universe, another puzzling entity emerges: dark matter. Its mass surpasses known matter by a factor of 5, yet its true nature remains elusive. TDLI is dedicated to uncovering the dark matter particles. In the Jinping Mountain in Sichuan, a tunnel located 2,400 meters from the summit serves as a direct detection site. The thick rocks surrounding the lab effectively absorb cosmic rays, resulting in one of the lowest radiation background facilities globally. Within this best environment, a liquid xenon detector operates and named Panda X.
We hope that future discoveries will be originated from here to unlock the deepest mystery of the universe.
Our focus now moves to neutrinos. Conventional telescopes allow us to view our universe by capturing the electromagnetic radiation produced by celestial objects. But when trying to observe the most violent and energetic processes in our early universe, this light is often easily blocked on its journey to Earth. Neutrinos are tiny, neutral particles that are unaffected by electromagnetic barriers, making them a novel messenger to probe the extreme universe. Leaping into this realm, TDLI leads the construction of an underwater neutrino detector 3.5 kilometers deep in the Western Pacific Ocean. The detector will be strongly shielded from cosmic rays, viewing the entire neutrino sky from its equatorial position. It expects to be world-leading in size and sensitivity compared to existing neutrino telescopes.
We are here at TDLI building a next-generation neutrino telescope called Trident.
Let's return to Zhangjiang, Shanghai, where 3 specialized platforms are at work. The Laboratory Astrophysics Experimental Platform employs high-relativity lasers to generate celestial-like extreme physical environments for simulating the evolution of celestial bodies. The Topological Materials Experimental Platform focuses on the discovery of novel topological materials and the realization of next-generation electronic devices. Augmenting our capabilities, we possess Xiyuan-1, one of China's foremost high-performance computing centers among universities. It provides essential simulation and computational support for scientific research.
So black holes are often referred to as the most mysterious object in the universe. They are one of the most extreme cosmic conditions. CUN Mark 1 provides the critical technology support for our research for the astrophysical black hole.
At TDLI, we have a close interplay between top-notch theoreticians and pioneering
Dr. Lee once said, "Science and art are the two sides of the same coin." He was not only a pioneer in the cross-border integration of science and art, but also interpreted the beauty of science from a unique artistic perspective. Now let's welcome son of Mr. Li Keran, the director of the Li Keran Art Academy, to deliver Tsung-Dao Lee, the integration of science and art. And now let's welcome Director Li Geng onto the stage. Distinguished Professor Li Zhongqing, Distinguished Director Zhang Jie, dear leaders, guests, dear colleagues, dear friends, hello everyone. So today, with the utmost reverence and remembrance, I would like to share with you the spiritual enlightenment brought to us by the Master of Physics, Dr. Tsung-Dao Lee. Mentioning Dr. Lee brings countless memories to my mind, filled with genuine admiration for his academic achievements and my deep gratitude for his humanistic spirit. On October the 21st, 2025, it marks the centenary of his birth, which adds a profound sense of remembrance and respect for this late Chinese giant who built a monument in the field of physics. In my eyes, Dr. Tsung-Dao Lee was not only a leading figure in the field of physics, but also with his profound insights into the course of human history and future development, left us a spiritual wealth that transcends academia. Especially in his later years, he vigorously advocated for the integration of art and science. Those wisdom concepts, like the lighthouses guiding our way forward, illuminated a bright direction for our exploration into the future. This inevitably leads me to recall the unforgettable moment of my first meeting with Dr. Lee. Back in the 1970s, he made a special trip to visit my father's home. He was a special guest to our home. At that time, my parents were in a period of recuperation. And through communications from the Ministry of Foreign Affairs and the Ministry of Culture and other authorities, we learned that a renowned overseas scholar was paying a special visit. I was still young then, assisting with note-taking on the side. I genuinely felt his gentle and modest demeanor. The conversation was filled with warmth. He calmly shared his experiences of academic pursuit and life overseas. Although there wasn't much specialized discussion about physics, but it revealed the scholar's humility and clarity. My father was naturally a man of few words, but had a unique habit when receiving guests. If he agreed to a meeting, he would always set aside 15 to 20 minutes for the guests to share their professional expertise and academic achievements. Fostering friendship and exchanging insights through culture, during that meeting, one small incident remains etched in my memory to this day, and often provokes my deep thoughts. Dr. Lee mentioned that he had attended an international academic symposium in Europe. During a break in London, he has the habit of visit museums. He was strolling down the street one day when a painting suddenly touched his heart. It aroused his homesickness. This painting depicted a young child, a water buffalo, and drooping willow trees. This sense of familiarity spanning mountains and seas reminding him of his homeland in his youth. And strengthened his resolve to return to his homeland. He confessed that perhaps it was that moment that ultimately led him to return to his homeland. My parents were quite moved upon hearing this. The conversation that day far exceeded the scheduled time, lasting a full 2 hours or more. Topics ranged from the homeland sentiments to scholarly pursuits, from art to science, with no one wanting it to end. On the day of the visit, Dr. Lee also gifted 2 precious art books. One was a very beautiful album on Impressionism, and the other was also a foreign language work introducing the history of Chinese art. Although this art history book was not lengthy, it was clearly structured, covering the development of painting from the Warring States period through the Tang, Song, Yuan, Ming, Qing dynasties. The last few pages also included works by artists such as Qi Baishi, Wu Changshuo, and Li Keran. Flipping through the album during the casual conversation naturally led to his core viewpoint. Both science and art are the most precious spiritual weapons of the mankind. After the guest departed, my father, as usual, asked me to recount my impressions and reflections about this guest. And he himself paid particular attention to the cutting-edge ideas brought by the physics scholar. What struck me most deeply from that meeting was still his sincerity when Dr. Lee spoke about that painting on a London street that seemingly a moment actually concealed his deepest attachment to his motherland. This sentiment of a wanderer is also the shared sincerity in the hearts of every Chinese son and daughter. Later, Mr. Lee and my father had a lot of exchanges and meetings talking about the topics like the art and the science. Even if I went abroad, I also heard that they corresponded continuously via letters. So today, I would like to share with you the second story that seems trivial but contains profound intellectual powers. Dr. Lee repeatedly explained the connection between art and science in public, conveying its core concepts with vivid metaphors. Those insights had a very crucial impact on both my father and me. During my study overseas, I heard that he had written over 12 letters to my father, specifically discussing science and art topics. He even, in 1989, wrote multiple letters, sincerely inviting my father to create posters for the World Physics Congress. My father was initially quite surprised, believing that the posters for a physics congress should focus on academic expression, but Dr. Lee insisted that the artistic conception of a Chinese painting should be used to cheer on physics. This unique concept ultimately led to the creation of 3 World Physics Congress posters full of the Eastern charm. This is the poster on the slide. Next, I would like to show you those immensely significant posters. The first one features 2 bulbs as the main subject, with the inscription colliding protons, tremendous force, using concrete brushwork to interpret the abstract physical principles. The second draws from the records in Song Dynasty literature about the world's first observed stellar supernova phenomenon, freezing this cosmic spectacle in ink and color. The third poster is the one I accidentally discovered later while organizing the documents at home, a highly expressive abstract ink painting, fully displaying the creative ingenuity of a science and art integration. As is well known, my father worked deeply in the Chinese painting world for many years, whether it's the majestics of Northern School landscape painting or the innovative practice of sketching from life. He had unique artistic attainments. He always held the concept of painting the mountains, rivers for the motherland as his original inspiration. In his youth, he even set forth the artistic vow, using the greatest effort to get in and the greatest courage to get out. These 2 phrases not only penetrate in his artistic life, also it has become widely circulated in this art world. Additionally, he once proposed his artistic statement, "What is essential is the spirit," emphasizing the spiritual core of artistic creation. So this maxim also received high recognition from Dr. Lee, who spoke with me about this multiple times, repeatedly praising its profound artistic insights.
In the mid-1980s, while teaching at a university in Germany, I offered 2 very popular courses on master students back then. One being Materials and Expression. This course encouraged students to create using diverse materials, whether it's modern materials like wood, metal, alloys, or traditional supports, or like traditional materials like a Chinese painting paper and oil painting canvas, and all the new modern materials and traditional materials all could become media for artistic expression. Especially in my research room, I especially introduced the high-quality papers unique to Asia, especially China, Korea, and Japan. So this is like Asia-specific high-quality papers has been encouraged to be used by the students. So the students, especially the foreign students, to explore the possibilities of a free creation on unfamiliar materials to them. This is a very innovative measure, highly sought after by the students. And during my teaching tenure in Japan, I continued this research direction. And this inspiration for teaching topic originated precisely from the insights on the scientific and art integration idea coming from Dr. Tsung-Dao Lee, of which he kindly shared during our meeting in my early years. So the integration of science and art. During my studies in Europe, I frequently visit a lot of art galleries and museums while contemplating, while appreciating the artworks, and ultimately integrated the concept of connecting the scientific and spiritual aspects of artistic materials into my teaching and try to instill that in my teaching practices, which gained widespread recognition and liking amongst a lot of young Chinese students as well. After returning to China, I was invited by Professor Wang Chuilin and other scholars from the Academy of Sciences, and along with my elder brother Li Xiaoke, so that together we can participate in the creation of the posters for the physics theory. My brother and I went all out, spared no efforts, continuously exploring within the practice of integration of science and art. And thereafter, I had the privilege of meeting Dr. Tsung-Dao Lee multiple times. Every time when we engaged in any conversation, I find it was the most rewarding experience of all during my life. I felt strongly about the great ideas I can learn from conversing with him. The core insight I was going to share with you today is my father, my mother, my elder brother, Li Xiaoge, and I consistently believe that Dr. Tsung-Dao Lee is not only a giant in the physics community, but also underpinned by his deep care and love for all humanity. The core of his thinking always revolves around people-oriented and compassion-hearted. So this sentiment and philosophy find its way into every thought of his and every practice of his as well. Therefore, he firmly believed that art and science hold equally lofty value, and although they belong to specifically different genre, they belong to different discipline. They have logical differences, yet they are interwoven with each other, mutually reinforcing each other and empowering each other. It's not simply interpreting each other, but rather those are important two pathways for human understanding of the world. As a matter of fact, since my early middle school years, I had a very profound realization. If human beings really want to express our inner thoughts and our intellectual understanding, we cannot do so without two important tools. One is text, the other one is graphics. First, the text is the carrier of linear thinking, so it possesses distinct sequential and logical properties, while it's unfolding its expression amongst a temporal thread. Well, on the other hand, graphics combines immediacy as well as a holism. It allows one to grasp the core meaning at one glance. Think about the Chinese character system. So think about which is like the crystallization of the wisdom. 图书馆 library. In Chinese, we call it 图书馆, 3 characters for library in Chinese. The 图书馆, which subtly contains the Chinese cognitive sequence and ordering of 图书馆. 图 means graphics and image. 书 means text and books. 图书 actually is the carrier of the historical records. Well, the first one, 图, is the visual representation, which means that the visual cognition comes first, followed by the books carries historical moment and written records. They together constitute a storage capacity and storage of human wisdom. And I always believe that cognition, application of graphics are crucial, like art. It can find its way into sculpture, painting, and all the other different ways of artistic expression. As a result of that, you'll find that from the graphics perspective, we believe that there is a most comprehensive existence within the realms of graphics as well. So across all the different fields, the value of graphics is ubiquitous. So the circles, the rectangulars, and the architect's pen can evolve into towering buildings, and the charts drawn by ballistics experts can accurately represent the flight paths as well as the changing velocity patterns. And doctors also need to utilize graphics to explain the human anatomy during the surgical teaching and diagnosis. And also, at the same time, think about text can interpret graphics. So text can interpret graphics, while graphics can provide a concrete support for the text. And the two are complementary with each other, they are symbiotic with each other, they are irreplaceable to each other. Art as the pinnacle of the graphical domain combines the color, composition, and lines. It combines multiple different elements, making a highly comprehensive form of creative expression. By contrast, the scientific research involves the scientists deconstructing and analyzing things through the abstract thinking and reducing them to their minimum smallest unit. As a result of that, they can use that to explore a lot of laws invisible to naked eyes, but they are existential in the nature. This represents two ways of cognition. It seems vastly divergent and different from each other, but by its very essence, it bears the height of the human wisdom at its height and peak, and they are the cornerstones for the progress of human civilization. Based on this type of cognitive foundation, my father, together with a lot of artists, when they are exchanging their wisdom, they have already gradually discerned the intrinsic essential connection between art and science. No matter its artistic principles of symmetry and asymmetry, or the cognitive logic of the concrete and abstractness, so they continuously find it manifest in the practice of integration of science and art. So this will meet the urgent need of our era for the diverse cognition as well. So Professor Tsung-Dao Lee, when talking about the relationship between the science and art, is used the metaphor of the two wheels of a train to draw some parallels. So in his mind, science and art are like the two wheels driving the human civilization forward. He proposed that if there is a train, it's speeding along, and if the one wheel is too large, well, the other too small, and what predicament will that arise? So this is a metaphor containing considerations of the timing, but at the same time it conveys a very profound sense of a crisis as well. So which suggests that only by collaboratively and coordinatedly developing science and art together, human civilization can steadily take some firm step and take some advancement making forward. So that's why. So echoing the points by Dr. Lee, so starting from the young scholars and the gifted young, so we have to expose them to the artistic training as well as the scientific training so that they can become artistic-minded scientists. So today, as we are remembering and paying tribute to Dr. Tsung-Dao Lee, not only for his outstanding achievements in the physics world, but also for his profound concern and foresight regarding the course of human history as well. His persistent pursuit of the integration of science and art brings us the most profound enlightenment and inspiration. In the future, we need to establish a more comprehensive thinking structure so that we can promote human society towards the brighter and rosy picture for the future together. So his concepts not only is inspiring us to love our life, to find a passion for our life, and also be brave enough to explore and innovate, but also pointing the way forward for us. I firmly believe that this path of the common origin and coordinated development and integration of science and art will ultimately lead us towards a brighter future together. At the end of the day, the integration of the science and art is going to lead us towards a very civilized and a brilliant future together. Thank you so much, everyone. Thank you, Professor Li Geng. Looking past the century, so Mr. Tsung-Dao Lee not only built a spiritual monument with his outstanding scientific achievements, but also sowed the seeds for the future in our hearts with profound thoughts. Last but not least, I would like to deliver a concluding report titled, so Mr. Tsung-Dao Lee and the Future, attempt to systematically review and prospect the future related to Mr. Lee. I hope that we can engage some discussion about as to how can we ensure the enduring, spiritual inheritance and legacy can be carried upon. At the same time, it can amplify its glorification for the future as well. So as the last report for our conference and commemorative events, first of all, may I ask you to look at those two pieces of a panoramic painting. So they carry profound meanings. So as a result of that, we can understand by blazing a trail for the boundaries of knowledge and trying to leaving a permanent mark for China's science and technology education. Over the past 1 year of commemorative events especially, so you'll find that a lot of excellent presentations, which are the highlights of our centennial commemorative events for Mr. Tsung-Dao Lee. I guess for his academic achievements as well as his patriotic feeling, we can understand and feel for that better. As a result of that, I come to the realization that so for a lot of the trailblazed by Tsung-Dao Lee has already become a vital on its own. This is a great existence of its own. So the passing of Mr. Lee will not stop there. So they wouldn't, for example, stop either. So it will not stop or come conclusion because conclusion of commemorative events. I guess a lot of great causes advocated by him is just like a vital seed being sown there with a lot of vitality. A lot of them break free from the soil already, emerging high at the same time. They're getting prepared for prospering in the future as well. So they already carry the meaning larger than its own. So I guess so this is the true effective continuity and the legacy of the spirit from Mr. Tsung-Dao Lee. I guess every member of this one is the guardian and beneficiary of the great forest planted by Tsung-Dao Lee. At the same time, we should sow the seed and become the navigator for the future generations. I guess the baton has already been passed honorably into our hands as well. So hereby, I still recall with vivid memory that in the year 2000, so Ms. Lee told me that the great Chinese nation should make a greater contributions to the progress of mankind civilization in the field of basic research. At that time, so China's scientific research enterprises has already entered this facility. We have a research paper patent application ranking amongst the top in the world. Just because of that, so I didn't fully appreciate the profound meaning behind the words left by Ms. Lee, but as time elapsed, I come to the profound understanding that Mr. Lee's pursuit is not only about the numbers or quantitative leadership for China's development, but we need to make inroads in quality and making some innovation in paradigm as well. What he anticipated was for the great Chinese nation to leave its distinctive mark in the epic quest of addressing fundamental scientific questions for mankind, and therefore making more substantial contributions to the advancement of human civilization. I guess this expectation in his letter to President Xi Jinping in the year 2014 becomes all crystal clear. He suggested that, and China should establish a top-notch fundamental research institute, quite like a Ball Institute, so to make sure that the 21st century physics as well as astronomy, core and also cutting-edge research for the dark matter, dark energy research should be carried upon, and find the bonding between the macro and the micro in the cosmos, and trying to understand most profound interconnection rules and laws of the nature. So this is exactly why our institute is established, and also with the support of the nation and the municipal government, and it was established in the year 2016 under Shanghai Jiaotong University, and based on the entrustment of Mr. Lee. So I'm glad to take the baton to become the director for the institute. This is my mission. This is the entrustment. So as a result of that, after multiple rounds of profound discussion, so we believe that the core scientific mission of our institute is that to focus on the two fundamental scientific questions. Well, the first one is that exploring the origin and evolution of matter under extreme cosmic conditions, which represents the shared research direction pursued by us, the particle and nuclear physics, astronomy, and astrophysics divisions. So these are the 15 years direction for us. Second one is led by the condensed matter physics division. We're targeting yet another critical challenge for human society development, achieving the universally futuristic high-performance computing capability.
To address the needs of exploring fundamental scientific questions, we have leveraged China's unique natural conditions to construct specialized scientific facilities in Shanghai, Qinghai, Sichuan, and Hainan, building extreme detection capabilities and forming an innovative research organization model and this larger size science research paradigm. So today, this paradigm has already borne fruit in the frontier fields. The planned construction of the Hainan Neutrino Telescope in the South China Sea at a depth of 3,500 meters by the TDLI, the first prototype of the photomultiplier detection string has been successfully developed. It is expected that the world's first small neutrino telescope near the equator will be built in 2026. At the same time, the Panda X experiment in Jingping, Sichuan, first observed the signs of the solar neutrino and coherent elastic scattering with atomic nuclei in 2024, indicating that the liquid xenon dark matter detector has reached a milestone sensitivity. And on the 4,300-meter Sichuan mountain, Lenghu, Qinghai, the JOST spectroscopic telescope is under construction. Its 4.4-meter aperture primary mirror and advanced multi-object spectrogram will review the large-scale distribution of dark matter and make decisive measures of the dark matter W that determines the future evolution of the universe. Dr. Lee's doctoral thesis focused on the hydrogen content and energy generation mechanism of the white dwarfs. In the basement, the laboratory astrophysics platform in this building uses high-power lasers to conduct researches on extreme astrophysical processes, explore the possibility of axions as dark matter. Also, in this same building, the topological material experimental platform serves as a quantum simulator exploring fundamental physics laws by studying the solid universe. These coordinated efforts of those platforms and bases not only led to the successful approval of our National Key Laboratory of Dark Matter Physics in 2024, but also strongly supported our comprehensive research on the properties of dark matter. Moreover, it closely connects us with our peers in the academic community jointly facing the most fundamental scientific questions. Dr. Lee's academic legacy continues to rejuvenate in the field of fundamental theories. In the area of QCD lattice calculations, which he vigorously promoted, we have made major breakthroughs and established the large momentum effective field theory. In the field of neutrino physics that he focused on throughout his life, multiple teams in our country are advancing from different paths, reaching new depths of exploration. And this Daya 1 experiment, to which he devoted so much effort, has already yielded fruitful results. And the Zhongmen experiment, led by the academician Wang Yifeng from the Institute of High Energy Physics, has now obtained the first batch of observational data measuring the so-called solar neutrino oscillation parameter theta 12 and its related mass parameters with a precision 1.5 to 1.8 times higher than the best international experiments in the field. In the IHIC physics, another field he championed, active research group have been established at the Central China Normal University, University of Science and Technology of China, Shandong University, Tsinghua University, Peking University, Fudan University, Huzhou University, University of Science, Academy of Sciences, Shanghai Institute of Applied Physics, and Institute of Modern Physics, and China Institute of Atomic Energy. Through participating in a large-scale international collaboration, those groups have produced a series of outstanding achievements. Meanwhile, the Beijing Modern Physics Research Center and the Zhejiang University Modern Physics Center, established on his initiative, have become vital bases for cultivating high-level talents, continuously advancing China's development in frontier physics. Beyond his scientific contributions, Dr. Lee has left us a rich spiritual legacy, tens of thousands of historical documents, manuscripts, letters, and medals, alongside the multitude of scholars nurtured by initiative he facilitated, such as the special class for the gifted young Caspier and also the fund. These elements has collectively pieced together the complete picture of his life, calling us to systematically carry forward, research, and promote his legacy. So today, under the leadership of Dr. Lee's eldest son, Professor Li Zhongqing, the Tsung-Dao Lee Library is embarking on a new journey. Our first priority is to transcend the traditional boundaries of this unique cultural space, truly integrating the functions of a library, archive, museum, science center, and art gallery. We aim to create a comprehensive educational environment that blends humanities research, the integration of science and art and spiritual scientists, allowing Dr. Lee's wisdom to take root and his spirit to endure. Simultaneously, we'll promote more open resources sharing. We are now currently collaborating with the Chinese Scientists Museum to curate a major centennial exhibition on Dr. Lee's life. We are also pleased to learn that Peking University, Zhejiang University, and Suzhou City are planning their own distinctive memorial halls and memories and museums. We will actively foster deeper museum collaboration to collectively chart a star map of Tsung-Dao Lee's spirit, and also converging the light of his thoughts into a more powerful force to illuminate the path for the future explorers. Regarding the research on Dr. Lee's thoughts and scholarship, we will build a global research hub. We will not only delve deeply into Dr. Lee's scientific educational philosophies, but also systematically conduct research on the unique communities such as the Caspier and the School for the Gifted Young. By pooling the wisdom of scholars from home abroad, we will form a vibrant Tsung-Dao Lee academic community, allowing Dr. Lee's wisdom to sparkle with light that guides the future through intellectual exchange. Looking ahead, innovative education remains core to inheriting Dr. Lee's mission. Leveraging the Tsung-Dao Lee class, we are addressing fundamental issues in cultivating talents in China's basic sciences, committed to nurturing exceptional individuals and future leaders with original innovations. At the same time, through the Tsung-Dao Lee Education Science Fund, we are systematically empowering basic education via 4 types of projects, including TD Lee School, TD Lee Scholarship. We aim to ignite scientific passion among youth worldwide and build an open international research ecosystem. We firmly believe this aspiration to aim high and scale the heights will guide the new generation to use the language of heavens to decipher the ways of things, opening new frontiers for the future of our nation and humanity. As is well known, Dr. Lee was also a paragon of the integration of science and art. In 2013, he donated to establish the Tsung-Dao Lee Science and Art Lecture Fund, using art to interpret science and using science to inspire creation. Facing the future, we firmly believe that the fusion of science and art is a source of innovation. Now this fund is being revitalized. The new committee brings together top scientists and artists. The scientific scope expands from physics to life sciences, astronomy, microelectronics, and other disciplines. The artistic dimension extends to painting, music, literature, and other fields, promoting the deep integration of scientific principles and artistic beauties to jointly inspire future-oriented original innovation. Today, we're gathering here at the core of Tianwen, a space named to honor Dr. Lee's scientific spirit and humanistic vision. Before us unfolds the 600-meter rotating scroll of heaven inquiry, or quest for infinity, collectively created by all the scientists, both home and abroad, of the TDLI. It captures the magnificence of the universe, beginning in the Big Bang, which also embodies humanity's enduring quest to understand the laws of cosmic evolution. At the highest point of the scroll, on the 6th floor, we find those words from Dr. Lee. Our Milky Way is tiny in the vast universe. Our sun, unremarkably among its 400 million stars, and our Earth, just a small planet in our solar system. However, because we have the Earth and humanity in this universe, that our universe becomes so beautiful and so imbued with scientific spirit and a humanistic feeling. And this grand scroll is far from complete. It will continue to unfold, awaiting each one of us to contribute new strokes with the courage to explore, the passion to educate, and the wisdom to integrate. May we prove worthy of this mission, using Dr. Lee's spirit as a lamp to illuminate the long road ahead, and guided by his words, lift our gaze to the distant stars. Thank you. Distinguished guests, dear faculty members and students, this morning we have reviewed the scientific achievements of Dr. Tsung-Dao Lee, and also we have also seen his nurturing talents of philosophy and his contribution to the great talents. We have also heard his pioneering insights and also his profound wisdom in integrating science and art. What Dr. Lee has left us is far beyond any single institution or project. It is an eternal proposition about patriotism, educating people, innovation, cooperation, as well as a perpetual spirit of exploring the mysteries of the universe and contributing to the human civilization. This legacy belongs to the entire Chinese scientific community, to the Chinese nation, and also to all human beings. Dr. Lee's life is the most vivid portrayal of deciphering the cosmos, exploring matter for a far-reaching future, and many of his visions for the future are still in the present tense, waiting for us to continue and realize them. On this great journey of building China into a world leader in science and technology, let's inherit Dr. Lee's unfinished work and spirit, advance courageously on the path of exploring scientific truths, devote ourselves wholeheartedly to the cause of nurturing young talents, and live up to our mission in serving the nation's development. May we all become bearers of the torch of Dr. Tsung-Dao Lee's spirit, allowing the scientific spirit and the patriotic sentiments he practiced throughout his life to shine with an even more brilliant light. Thank you very much.
各位来宾，
Distinguished guests, the centennial commemoration of Dr. Tsung-Dao Lee has now concluded successfully. Please exit in an orderly manner and proceed to the dining hall for lunch. Thank you.